The first thing I needed to understand is what we're transitioning from. And for electricity, that's coal. To get a better look, I went to the Bellaire mine, which makes enough energy to power 3.6 million people per year. It's in the Powder River Basin, the largest coal reserve in the world.
Fire on 24. Yeah, everybody holds position 5-3rd shot.
We will clear the blast momentarily, and we're safe to mine.
Is that right?
In minutes.
Wow.
There's the coal inventory right there.
That is a big pit.
The Powder River Basin has a typical coal seam of about 100 foot thick. So,
I mean, it's just big, thick black seam down here. It's unbelievable.
the mine, it looks enormous, but the mine moves actually quite a bit. We will move about 3,000 feet a year across the landscape. Okay? So these big terraces are excavated on the cut side, we call it, placed back on the dump side. This will all be reclaimed, and the original topsoil that was taken from this area will be placed right back directly where it was taken originally.
It's kind of hard for me to get a feeling for scale. I mean, I see little trucks driving around out here. They look like the little Tonkas I used to play with.
That is the largest mining truck in the world, Scott. That's the Caterpillar 797. That's a 400-ton payload truck. This particular machine is the largest rope shovel in the world.
And the price tag?
It's about $30 million.
$30 million bucks.
With the bucket and all the accessories.
Take care of it.
Wow.
This is amazing.
That's a lot of material.
Put it in perspective, the volume of material we dig annually would be 3 Panama canals.
Every year.
Every year.
The whole Panama Canal?
The entire Panama Canal.
Many people think it's that dirty black stuff,
Yeah.
but in fact it's been powering a good fraction of society for a couple hundred years. So there must be some upside, right? Coal supplies about half of the electricity generation in the US and globally is also about half, maybe a bit more of the primary energy. So the world gets a lot of its energy from coal right now.
And there's a lot of coal left.
There is a lot of coal left, hundreds of years.
Yeah.
In fact, nobody really knows because nobody's gone exploring for coal for many decades.
Every day we ship approximately 80,000 tons of coal. That coal that you see right here was probably mined 4 to 6 hours ago.
And how often you move a train through here?
We do 5 trains a day.
Wow. So it's just a steady flow.
Steady flow of trains, 24 hours a day, 7 days a week, 365 days a year. We ship coal on Christmas, Christmas Eve, New Year's Eve.
Somebody's always
getting coal.
How much coal are we looking at in the Powder River Basin?
There's literally billions of tons of reserves.
Give me a feel for what that means in terms of just U.S. supply.
Powder River Basin represents 50% of that.
So make sure I understand. About half of our electricity comes from coal,
Correct?
and about half of that is coming from the powder.
And half of that is coming from right here, this quiet little community in northeastern Wyoming.
Who knew that?
I think very little people do know that.
So coal is global and easy to produce. Is supply the only reason we're still hooked? I followed the trains to America's largest coal plant, which could power 900,000 people per year.
All these cars have got a rotary coupling on them, so the cars will spin on the coupling.
Okay.
And you watch what's going to happen. These clamps are going to clamp down on top of the car. Then this whole dumper is going to turn upside down,
Track and all?
track and all.
Trains are running.
Around the clock.
Yeah.
Trains running around the clock, unloading coal around the clock, moving it to the units, making electricity 24 hours a day.
So this is awful big.
Well,
We've got coal coming from the coal yard out there going through this conveyor. That coal is going into each corner of the boiler, makes a big fire in the boiler, heats up water inside the boiler, heats up the steam. Steam turns the turbine turns the generator makes electricity for Texas.
Take a massive global fuel supply, combine it with fast, simple power generation, and you get the cheapest electricity in the world. That's why we're still hooked. So the big driver really in many ways is the economics.
As in almost all things energy, economics really runs the whole show. On the other hand, coal has these external problems with it. Local air pollution, sulfur in particular, and then the global problem of carbon dioxide emissions.
Right.
If the world is going to continue to use a lot of coal and do it in an environmentally responsible way to protect the climate system, then we're going to have to develop and deploy the carbon capture and storage technology that's now really in demonstration around the world.
We've got a project we're working on in the Department of Energy to remove carbon dioxide out of our flue gas. We're going to prove that it can work on a coal unit. We're going to try to prove that it's economical to scale up so we can do a full-scale unit.
Okay.
And then we can actually capture the carbon and put it to good use.
Gotcha. So you're going to have another module, if you will, to remove the CO2 from that stream before it goes into the stack.
That's right.
I went to see NRG Energy, who owns the Parrish plant, to find out if we could really clean up coal.
The traders, that's the real-time desk with the 10 screens.
I noticed the board had all your competitors.
Yeah. You've got, on one hand, the coal industry saying what they're doing now is clean coal, and I think that violates the truth in advertising. I actually think it's really unfortunate that they spend a lot of advertising dollars pretending that what they're doing now is clean coal. On the other hand, you've got the environmental movement saying that it's an oxymoron. There's no such thing. I think that there actually is clean coal, and clean coal it should be defined by the carbon emissions. And if you can get the carbon emissions from a coal plant down below the carbon emissions from a gas plant, so more than 50% down, then to me, you fit the definition of clean coal.
Right.
Our company got an award to do a project down in Texas.
That's at Parrish?
That's at Parrish. We have a grant from the Department of Energy, around $140 million, and we have to match that, so it'll be about a $300 million investment. So you see the type of money we're talking about in terms of learning how to capture carbon. These are very significant dollars.
Sure.
$300 million to get just 2% of the CO2 at this one plant. Even as the technology improves, that means capturing half the carbon from the world's fleet of coal plants would cost trillions of dollars. We probably could make coal clean, but we probably can't afford to.